Alright, so we made it to our last box. We created a controller, we created a service, we created a repository, and we created a model. We were able to test out the flow of the controller service repository flow using Postman, and that acted as the client to our endpoints. We were able to test adding a to-do, updating a to-do, deleting a to-do, and getting all of the to-dos from the database, right? And everything worked as expected. But sometimes in life or in programming, right, got a little bit philosophical there, but sometimes in applications, or a lot of times, things don't go as expected. Sometimes YouTube is down, sometimes Google is down. You know, not for too long, because in the back end, I'm pretty sure they have ways to reconcile that. But in our case, we have not set up a way that if things don't go as expected, it will return a response that's nice back to the client. Because we don't want to freak out the client, right? We don't want them to see something that they didn't expect to see. We want to send it in a format that they will be able to understand, right? We want it to be a clean error. So that's what this last box is all about. It's all about exceptions, because the definition of exceptions, or an exception, is an event that disrupts the normal flow of the program. All right. So like I said, things happen. So when that flow gets disrupted, we want to be able to catch that exception and return a response that the client understands, to be able to show back to the user that, okay, at this time this application is not working. Come back later, or try again, something like that. Instead of it being a whole stack trace of all the errors that we just saw in our application, that would be a problem. So let's get started. Let's start creating some custom exceptions for our application. So let's dive back into the code. Alright, so now we are back in the application. When we first created the structure for the application, we also created a folder called config. In this folder, or in this package, we expected to put configuration files in here. And a configuration file that we will create, or that we will need, is a configuration file for our global exception handler. All right, we're going to leverage an annotation called controller@device, which will allow for exceptions to be funneled to this configuration file, and we'll be able to handle those exceptions in ways that we define within that file. So let's get started doing that. So let's right click on this config package, create a new Kotlin class, sorry. And then we're going to call it custom exception, or custom controller exception. Alright, boom, finally spelled it properly. And this will be the class that will start creating some functions that will handle specific exceptions that are thrown by our controllers. All right, and so like I said, we're going to leverage an annotation called @controller@advice. Boom. And what controller@advice allows us, and let me zoom this in, I always forget to do that, but what controller@advice allows us to do, it allows us to handle exceptions across the whole application in one global component. This component in this case is going to be custom controller exceptions, and it can be viewed as an interceptor, right? So all of the exceptions thrown by methods using the annotation like request mapping, post mapping, get mapping, so pretty much controllers pretty much. Whatever an exception is thrown by those methods or functions, they'll be funneled to this class first, and then we'll have some functions defined that will handle certain exceptions that are thrown. So we can handle all exceptions, or we can handle some exceptions that we define in this class. I'm going to create one function that will handle all of the exceptions, but then I'm going to also create another function that will handle a specific exception, just so you guys get the best of both worlds. So before we do that, like I said, we're creating this global exception handler because we want to send a clean response back to the user. We want to, or back to whoever is making the request, right? So the client. right? So we want to make sure that it's in a structure that they'll be able to digest properly. So now we're going to create an error response that will allow for our client to be able to receive a clean response back from the application when an exception does occur. So to create this error response, I am actually going to put it in the models folder, because usually when we define how a structure should look like, we usually put it in the models folder. So let me right click on the models package, create a new Kotlin class, and I'm going to call this error response. And I'm going to zoom in. All right, so now we're going to start defining some of the fields that we will expect for our error response to include. So one thing that I want to include is a timestamp, because when an error does occur, I want to know at what time did that occur. So I'm going to make this equal to date. Okay. And in this case, I'm just going to make it equal to null. And then I am going to move on to the next one. So the next one is going to be the code. All right. So if you looked into my HTTP tutorial or explanation on what is HTTP, which I'll leave a link somewhere on the screen, there are different codes that are assigned whenever you receive a response. So you can receive a 200 to show that you received, it's okay, you received something. You can receive a 404, meaning that there was some type of error. You can receive a 500, which can be like, okay, there was an internal server error. It's on us. It's on the application in the back end. There was something that we can't resolve at this time, but we're just gonna let you know we're using a 500. So these are the type of codes that can occur. So we want to provide that code to the user. So I'm going to create another field called code, and I'm going to make that equal to 0. And then we're going to actually create a status, which is going to be a string. And that's going to be synonymous to the code. So like, if it's a 500, like I said, then the status would be, okay, it's an internal server error. So that would be the string, internal server error. And I'm also going to make this null. And then the message. So whatever error message looks like, we can pass it into this message variable, and at least the user will be able to retrieve what exactly occurred using this message. And I'm going to make that equal to a string, and initially I'm going to make that equal to an empty string. And we're good. So the first thing we're going to do is we're going to start defining different scenarios on when this error response is called. So by using constructors, right? So say for instance, because we're going to give the user an option of using some of these fields to create an error response. And let me actually not put some space here. So we're going to give the user an option of generating a error response based on the fields that they pass out of these 4. So if they pass in a timestamp, but they don't want to use a code, status, and message, that's fine. Then we'll just generate a error response with just a timestamp. Everything else is going to be the default value. And honestly, the status can also just be an empty. It doesn't have to be null. All right, so now let's start generating some constructors that will allow us to format the error response in a way that the user expects. So the first constructor I'm going to create is a constructor on if they don't pass any parameters. All right. So the only thing that we could probably do is, make sure that the timestamp is actually equal to the current date, right? That's all we can do. If they don't pass in anything, right? We can't just assume what type of code is going to be the status message as of now. We're just going to pass the current timestamp. Then we're going to create another constructor. And now we can start defining some parameters. So this is overloading, by the way, if you don't know what constructor overloading is. I have a whole Kotlin series. If you do not know what constructor overloading is, I'll leave a link somewhere on the screen. But we're going to start defining some parameters. So in this case, I am going to define HTTP status. And this is going to be of type HTTP status. And then I'm also going to take in a message. And we're just going to make that like required. Like this is not going to be nullable. It's going to be required. Open that up and let's start constructing how we expect this to look like. So the timestamp is always going to be the current time when this error response is actually being generated, and the code is going to be equal to the HTTP status dot value. That's going to return the actual code number, and the status is going to be equal to the HTTP status dot name. That's going to be the actual like string value of the HTTP status. So remember what I said, if it's like an internal server error, that means the name is internal server error and the code will be 500. So, and then we'll assign the message, and we're going to make sure we use this here. This dot message is going to be equal to message, just to make sure that it knows that this, meaning this message right here that belongs to this class, is going to be equal to the message that is being passed to the parameter. So these are the two constructors that we are going to leverage to create or to generate our error response. You could create more fields if you want. I wanted to keep it as basic as possible. You can even include a field called stack trace, which will, stack trace is simply whenever an exception is generated, stack trace just explains in a very fat manner what occurred that caused that exception to happen. So if you want to scare your users, you can also add that field and send it back. I don't recommend that because stack trace is just so big, but it really depends on what type of application that you have. Yeah, but usually a message is just enough just to let the user know, okay, maybe this ID wasn't found or something like that. So I just kept it on status code, timestamp, and message. That'll work for now. And now we can go back to our custom controller exceptions, and now we can leverage that error response that we just created when we start defining our custom exception handlers, right? So whenever an exception is thrown here, now we can create some functions to handle those exceptions. Let's define our first exception handler, and I want this to handle all exceptions, right? So say for instance, there's so many different types of exceptions in Java. There's runtime exceptions, there's just a parent exception. There's different exceptions. There's duplicate exceptions based on say for instance you have a database, which we do in this case, and you try to save something with the same ID, right? And IDs are supposed to be unique, so there's going to be a duplicate exceptions, things like that, right? All types of exceptions will be caught by this exception handler unless we specify another exception handler that will cover specific exceptions. But in the case we don't want to write exception handlers for everything, right? Not right now, but there's so many exceptions that we may just want one global exception handler, which we are going to create now. So I'm going to call that a function of handle exceptions, and this is going to take in one parameter, which is the exception itself. So exception is the parent exception, right? Like I said, there's so many different type of exceptions, but it is all sub classes of an exception. So we will be able to capture all exceptions using this exception. And then we're going to make this function return a response entity, because we're trying to send a response back to the user that is going to be of type error response, because we just created a structure called error response, and we want to make sure that we return back to the user that error response in that structure. So we're going to use a thing called response entity, which will allow us to send a JSON version of the error response back to the user or back to the client. We didn't use response entity in our controller, but in this case I want to send a response back to the user in a JSON format, so I'm going to use response entity. And later on we're going to actually go back into the controller and probably change a couple of the endpoints to use this response entity. Response entity, and we're going to give it a type of error response, because we're letting Kotlin know that this is going to be a response entity that is going to look like an error response. And now we can just open up the function and start adding some logic. But before that, like I said, this is going to be an exception handler. And to let Spring Boot know that this is going to be an exception handler, we can use an annotation. You guys got to be used to that by now, right? Everything is annotations, but it just does so much, right? So we're going to make this an exception handler. Perfect. And we're going to open up some parentheses, and we are going to let this exception handler know that we want to handle all exceptions or things that are using the exception class, right? Like I said, exception is the parent class of most or all exceptions, right? So if a runtime exception is pulling from the exception class. So if we want to make sure that this is able to handle global exceptions, then we'll need this exception handler to let the application know that all exceptions can be funneled to here, and we'll write some logic and we'll send a response for that exception. Now we want to make this handler very generic, right? Because it's handling multiple types of exceptions. So what we're gonna do is we're gonna make the status, right? Because we're taking in, remember, when we created this error response, it's gonna take in a status, code, timestamp, and a message. So I'm gonna leverage that, right, by making sure that I have a status that is equal to HTTP status dot internal server error. Now what this status means is, okay, we have an error in the server and we simply cannot handle it. So come back at another time when we fix that, right? So this is a very good status to use when there's an issue with our backend, with our application, but at this time we don't know what it is. We're trying to fix it. So if we're using a very generic exception handler, I think this is the perfect status to use to let the user or let the client know that at this moment our application is not working. We're currently debugging it. So we're going to use that as a status. Now we can actually return a response entity because we have the status, we have the exception which will hold the exception message, and the timestamp is going to be generated automatically when we call to create an instance of an error response. Because if we go right here, if we just pass in the status, we pass in a message, this timestamp is going to be created right when we create an instance of an error response. So we are good to go. And the HTTP status holds the code and the status name, so we don't need anything else. So let's return that. Let's return a response entity, and just to specify, right, we can specify a type of error response, and because we told this function that we're actually going to return an error response at the end, so just to specify that. And then inside of these parentheses, I'm going to create an instance of an error response. And the first thing was status, so I'm going to pass in the status that we just created above here. I am going to pass in the message of the exception, so all we got to do is use the variable name of E and then dot message to grab the message. And then that's pretty much it. Now let me see what's the issue here. Required HTTP status code. We need to add in, so it takes in two parameters. It takes in the error response and then it takes in the status. Totally forgot about that. And in this case, let me see what this, okay, because this exception message could be nullable, we have to make the error response message nullable. So let's go back. And we're gonna have to change this initial variable that belongs to this class to null, because if we try to pass a nullable message from the parameter to this message, that'll be a problem because this is not accepting null right now. So we have to change this main one to null as well, nullable as well. Okay, cool, and that should work now. So now we created a global exception handler. If an exception gets thrown, then this will catch it. And it will send a error response with the status of internal server error as the code and the name, and a message of the error that occurred. And the status is actually being returned as the same status as here. Cool. So now let's create one more exception handler. But we're actually going to make a custom exception as promised. So I'm gonna right click on this exceptions folder on the left, because in our structure, on our first video, we created the structure and exceptions was included into this, and I promised that we were going to make custom exceptions, and all exceptions that we're going to customly make will go into this exceptions folder. So let's right click, press new, Kotlin class. I'm going to create one like custom exception when data is not found, because there is cases where if we try to delete something with a specific ID and it's not there anymore, it was already deleted, or if we try to update something and somebody try to use an ID that is not in the database, that is not found. All right, so that is a scenario that of an exception that we can create. So let's create that exception, data not found exception. Boom. Let's zoom that in. Now this should be relatively short, right? So like I said so many times, all exceptions are sub classes of exception, right? Exception is the parent. So what we're gonna do is we're gonna do as others, right? We're gonna extend exceptions, and we have to, define some constructors, and we're gonna do super. That refers back to the parent class. So, but we also want to make another constructor, and we want to make sure that they're able to pass in a message, and it's going to be a type string, and we're going to make a call to super, which, like I said, refers back to the parent, and we're going to pass that message. As you can see, an exception accepts different types. Like it accepts a string, you can accept a string and a throwable, it can accept just a throwable, and it can accept a message, which is of type string, a throwable, a boolean, and a writable stack trace boolean. So but in this case we're just going to leverage just the message, but you guys can play around with that as well if you want to. But in this case I'm just going to leverage a empty constructor, and if they want to send it a message, we can do that as well, while leveraging the exception to make our custom exception. Perfect. Now let's go back to the custom controller exceptions, and then creates a exception handler in the case that something is throwing a data not found exception, and we're going to add that data not found exception in our controller right after this. But let's create a function called handle custom not found exception, and then we're just going to open up some parentheses, and we're going to find that we're going to accept the parameter of exception just like before, and then we're going to open up the brackets. Now to let the application know that this is going to handle data not found exceptions, we'll just use the annotation exception handler, and then we're going to open that up, and then we're going to define that it is going to take in data not found exception, and then we'll just define that it's going to be using the data not found exception class that we just defined. Cool. So whenever a data not found exception is thrown, this will catch it, and now we'll start writing our logic on what would happen, what will be sent back to the user when that happens. So same approach. I'm going to create a variable called status, and I am going to make that equal to http status dot, but in this case not found, because like I said, this is going to be thrown when information is not found. So this is, I believe, a 404. Let me actually go to the definition of this, so I can actually go into the class and I can see, yes, data not found is a 404. That's forbidden. There's so many different types of status. Let me zoom in just in case you guys can see. But there's so many different type of status that can be shown back to whoever is making a request. So I'm going to be using 404 though. But yeah. So let's go back and let's do the same approach. Let's return a response entity, and I actually forgot to let this function know that we're going to return a response entity of type response. And then let's actually do that. Let's actually make a response entity of response. And then let's open that up. Let's do response. Let's define or pass the status. Let's pass the message of the exception. And we got to make sure that as a second parameter for this response entity, we pass the status. And we are good to go. So we created two exception handlers. We created a global exception handler, which just handles exceptions. So it will handle all the exceptions that are not included in this exception handler. So we have an exception handler specifically for data not found exception. But if this was not here, then this global exception handler will take that, right? But because we have this right here, it is going to handle our data not found exception specifically. So that's great. But if it catches anything else, then this handle exceptions handler will handle all of that. So if it's a 403, if it's a 500, well, this is gonna show it as a 500, but it will catch it, and it will send it back in a format that we specified in our response model. So cool. Now it is time to adjust our controller to throw specific errors, and we can try to catch whenever an error occurs, because like I said, you just never know when something may go down. So like, say for instance, okay, our application is running fine, but what if our database is down? Now whenever we make a call, it's going to throw an error because okay, that information was never saved. So there was an issue. The database is down. So how do we tell the user that, right? So we have to make sure that we're sending them useful information to know that, okay, first, that information was not saved. So we shouldn't show the user that information was saved. We should let them know, okay, something happened, it wasn't saved, and try again later. So there's different scenarios that can happen. So let's actually go back to the controller so we can add that logic. And honestly, like I said, the controller is not really used for all that logic handling. We're actually going to go into service, because service is going to do all that logic. And look how clean this looks. Like, we don't want to ruin that. So actually, let's go into the service and handle all of that. Let me zoom that in. So first, let's do update, right? So first, let's make sure that when we receive an ID, right, from the entity and the URL, we make sure that those IDs look like each other. So we can just do a simple if. It's just a simple little validation check. But yeah, let's do that. All right, and we're just gonna make sure that the to-do entity, the ID, is equal to the to-do ID. Just a simple thing. If it's wrong, if it's misplaced, then that means we could probably just not even try to save it. That would be a waste of time, because we're trying to update something that doesn't even match the ID that the user sent, right? So, or maybe someone maliciously was able to retrieve the request and try to change things. Like, anything can happen, right? So this is just a simple check that we can do. Obviously there's stronger ways of doing that, authorization, authentication, but just for this tutorial. And let's make sure that when we do attempt to save this, like I said, maybe the database is down, we have to try to do all of this. But if an error does occur, right, we have to be able to catch that error. So try and catch, and if an exception occurred, then we'll be able to throw our custom exception. So if you don't know what a try and catch is, it's gonna attempt to try the logic that you put inside of this try block. But if an exception happens while trying to do whatever you put within this block, then it will go to this catch block, and we'll be able to do some logic within the catch block. In this catch block, I'm actually just going to throw an exception because there's different things that can happen. Maybe the database is down. Maybe it's just unable to do it. There's so many different things. So I'm just going to throw an exception here. And remember, our global exception handler should be able to handle whatever occurred, whatever exception occurred. But put it in a format that is clean for the client that's requesting it. So let's just put as the message, because remember, we can define a message. So let's do unable to update data with ID, and then we'll put in the ID. Cool. And then if let's actually remove this return and put this return right before the try, and then that if it gets to this last line, then it's just going to return the saved instance of to do. But if it gets to outside this if block, right, if this is not true, this ID doesn't match, then we can just throw our custom exception, throw data not found exception, and we're going to pass in a message, IDs used, we've got to make it a string, IDs used not valid, or ID used not valid. They'll have to try to figure out which one, right? So we got to make sure that the ID matches, or the client that's calling it to make sure that the ID from the entity matches the ID that's being passed in the URL. So ID used not valid. Cool. And then that is the logic for the update. It's going to first check if the IDs match. Then it's going to try to save the information to the database. If an exception occurs, then we're just going to throw an exception. The global exception handler would handle that. And then if these IDs do not match, then we'll just throw that the data can't be found, like they don't match, right? So IDs used not valid. Now let's actually do this for attempting to delete an item by an ID. So remember, this is just returning a string. I said I was going to come back to this and actually use a response entity. So let's do that. So let's make this a response entity. And in this case, I'm actually going to make this into a JSON format. Like the response entity is going to make it a JSON format, but I'm going to make sure that it is in a data value set. So I'm going to use, or key value set. So I'm going to use a map, and I'm going to make sure that the key is a string and the value is a string, because I want to send it back to the user as the data being the key, and the value is going to be the message that I'm trying to send. So let's do that. So then it's going to be the same thing, right? I want to make sure that this is the error, if it does occur, is being caught properly. So we're going to do a try catch. Open that up, try, and then close it. Use a catch. Open that up, and then so the exception type that we're going to use in this case is a empty result data access exception. So this is in the case that we're trying to delete something, or delete a to-do of an ID that doesn't even exist in the database. So we can throw this exception, or we can handle this exception in this catch block. And we'll open up that catch right here, and this will be the perfect place to put our custom exception. That's not found exception, unable to delete item ID not found. And then let me see, this is void, so it's not going to be able to return anything, but we'll create our message if it does succeed. So it's going to attempt to delete it. If it does delete it, then we'll create our message structure. So I'm going to create a val called data message, and I am going to make that of type mutable map, and I'm going to make that equal to string, or the key value pair of string string, and then it's going to be hash map. And actually, let me fix this misspelling, and then we're gonna make sure that data message has a key of data, and that data is equal to properly removed. And then we're gonna create a response entity. It's gonna be of type OK. And then we're gonna send the data message as the message, and that should remove all of those swigglies. And then let's remove that bottom piece, and we're gonna use another catch, right? Because we can stack up catches. Like if it doesn't match this empty result data access, it can be another type of an exception, right? So like I said, we can use the type of exception to catch, you know, different types or all other types of exceptions, because this is the main parent exception. So all other exceptions will go to this catch, and we'll just throw it and let the exception handler structure it in a way that we expect. So we're going to throw this exception, and then this global exception handler will handle that and format it properly. So we have to go back here, and we got to make sure that this is returning what is expected. It's going to expect a response entity of map of string, and we will return that for this endpoint. And once we have that, we should be good to go to test this out. So let's run this application. And this is probably gonna take a little bit for me. I have a lot of things running, but once this is built up, we can go into Postman and test these endpoints. All right, so now it is the perfect time to test what we just implemented. So remember I added that property in my application.properties that if I restart my application, it's gonna drop everything out of the table, and it is going to recreate the tables. So everything is empty right now. I can actually test that right now using the get. If I send it over, there is nothing in my database. Now we're gonna have to add data again. So we do first and send that. Actually, I think I add multiple. Yeah, I did by accident. So I added two things, 1 and 2. So now it is time to test what we just implemented. So let's go into this delete to do. And actually, let me confirm that everything is there. Let's do a get. All right, cool. We got 2 entries. And now we'll delete the first one. And actually, let me just pull this up. Whoops. This was what I need. All right, cool. So now we have it in the structure that we expected. Remember, we made a map. And if it is properly removed, it's going to put a key value as a response. It's not just going to be a plain text like last time that just said deleted. Now it's in a key value format. It is showing data as the key, and the value is that it was properly removed. But what if I try to delete the ID that I just deleted? What would happen? Well, I know it should break, right? But is it in the format that I should expect? And also, another cool thing is that you can see the status right here. Remember that I put response entity.ok, and then I passed in the data as the message that we're returning back. So that shows that the status is being received by Postman. So back to what I was saying. So what if I delete something that I just deleted, or try to delete something of an ID that doesn't exist in the database? What happens? So let me just try that. Let me try to delete 1. I know it doesn't exist anymore, or it shouldn't. So if I send it, boom. All right, cool. So now we get the format that we expected. We get a timestamp because we defined that field, right? We defined timestamp. We got the code, right? Remember, if it's not found, because this is returning or throwing a data not found exception. We created this, all right? And the code, remember, like I said, if it's not found, then it's going to return the value of the status, which you can also see right here. And it's going to return the actual status name, which we can also see right here, not found. But we see it here as well. And it's going to return the message that we defined when we threw the exception. So now, instead of it throwing like some long, confusing exception message, it will just return the message that we defined. So it's unable to delete the item, ID not found. Perfect. So you see how useful this is? All right, this is amazing. And we can also check this in update to do. So what if we try to update something that is not there, right? Or we try to use, actually, let's not even do that. Let's try to do the mismatch scenario that we expect, right? What if we try to use an ID of 3 here and a ID of 1 in the URL? What happens? Boom. Same thing, right? It's throwing a that not found exception because it didn't pass through the if logic that we created. So now it's showing a code of 404. Status is not found. It's being shown here as well. So Postman is able to read that status that we returned, because remember the second parameter of the response entity is the status that we're sending back. So that's how Postman knows that this is a 404 and not found. And the message is the message that we defined when we threw the exception. So ID used is not valid. So you see how clean the structure of our response is. This is all error response, and you know, for every exception that we have in our application is going to be in this format. So that making this exception linear, first of all, so that your clients will be able to handle all exceptions the same, and also it's just in a nice format, so you know they know what type of exception it is, and what to send back to the user. Okay, we could just say, okay, user, this ID is not valid, or maybe you don't want to give out too much information. We just say that we can't do that at this time. So there's many things you can do, but that is how you send and create your own error responses, and that's how you handle exceptions. So we created a controller, we created a service, we created a repository, we created a model, we created an exception, we created a config for our exceptions, we created a functional REST API locally, and we are able to test them using a application called Postman. I hope you guys found this tutorial series informative, and I hope you enjoyed it. Leave a like and subscribe if you want to see more. I could possibly do more Spring Boot stuff. I know I'm possibly going to do more AWS stuff, probably Spring Boot and AWS together, and I'm going to most likely continue on with this in the future, maybe add some authorization and authentication. So yeah, there's a lot of things you can do, but I do recommend you guys play with it, add your own exceptions, add your own models, add your own services. Just play around with it. The more you play around with it, the more you will learn. So hope you guys enjoyed that.